So now we are going to discuss about sample space and events. Both of these are the very important features of the probability theory. So what is sample space? Starting from the sample space. First we define the sample space. So the sample space, that is also called outcome space, is the collection of all possible outcomes of a random experiment. Last time we discussed about the random experiments, and so sample space, what is this? Is the all possible outcomes of that random experiment. Let us consider the tossing experiment of tossing a die and observe that number that's shown on top. So this is the random experiment. So what is sample space in this case? Sample space contains the values 1, 2, 3, 4, 5, and 6. If we throw a dice, these are the possible numbers that we will get. So events. What is event? An event is the subset of the sample space. So we are just looking for the examples so that if we throw a dice and an even number occurs, so that is a event. So event that is denoted by a is equals to 2, 4, 5, 6. 2, 4, and 6. This is the event that an even number occurs. So a number greater than 2 occurs. What is the event that? What are the possible outcomes for this? 3, 4, 5, and 6. This is greater than 6. This is also an event. And a number greater than 6 occurs. Is there any possibility that any number greater than 6 occurs in this throwing a dice? So there is no such numbers, and so event is 5. 5 is our event. Next we discuss about the experiment. Toss a for coin 4 times and observe the number of heads obtained. So what is sample space in this case? Sample space is 0, 1, 2, 3, and 4. If we toss a coins 4 times, and number of heads would be, if all the coins there may be no head, all of these are tails, so sample space is 0. There are 1 head and 3 tails, sample space is 1, and possibility that all of these are the 4 head, so sample space is 4. Now we define different events. The 2 head occurs. When 2 head occurs, event A is equals to at least 2 head occurs. So our event is B is equals to 2, 3, and 4. Taking another experiment, they that manufacture items on a production line and count the number of defective items produced during 24 hours. So sample space should be, there should be numbers should be 0, 1, 2, and up to n, where n is the maximum number that should be produced in 24 hours. If maybe all of those are the events that have all of those are the products defectives, and there may be no defective products. Event all items were non defective. So what are the event in that case? So that is equals to 0. Experiment, we are taking another experiment, that a light bulb is manufactured. It is then tested for its length by inserting it into a socket and the timeless during. So what is the sample space in this case? So sample space is that time is t, and t greater than equals to 0. Any number that is greater than equals to 0 is our sample space. In this case, it bulb burns less than 3 hours. So one, then our sample space is t. So that t is less than 3. Sorry, that was the event. Now we have one more important part, mutually exclusive events. What is that? So if we have two events A and B and they can't occur together never, then that events are called the mutually exclusive events. Suppose turning left and right at the same time. It's a mutually exclusive event because we can't turn on the both sides at the same time. Tossing a coins head and tails. Getting head and tail at the same time is also not possible. That is also mutually exclusive events. So these are the topics we have today discussed. Topics are events, sample space, events, and mutually exclusive events. Thank you.